post questions in the chat. So welcome everyone to the last day and the third day of this ETIP Bioenergy SPM 10. I'm really looking forward to your contributions and the discussions. I think the last 2 days has been really exciting, and we have a big task ahead of us, and a lot of interesting subjects, both on the technology and policy and research and innovation. So with that, I will leave over to the moderator, Calliope Panoutsou from Imperial College, to moderate this third session today. So Calliope, the floor is yours.
Hello, good afternoon, everybody. Thank you very much, Patrick. We are here, as Patrick mentioned, for the third day of this very interesting conference, and we are going together with colleagues to discuss a bit the issue of sustainable feedstock supply and provision through the context as set by the Renewable Energy Directive. So I will make an introductory presentation, and then I will welcome the other participants and speakers to illustrate some of the practices based on their long experience, both in cultivating crops in unused or marginal land, but also on applying practices such as rotation or cover cropping or climate smart agriculture to improve the soil, the biodiversity, account for the ecosystem services within the local context, of course, of the application, and also ensure sustainable feedstock supply for advanced biofuels. Just to give you a little bit of the context where we are going to focus, we do acknowledge that RED has set a target that after the end of 2023, the use of high ILUC biofuels, high ILUC risk biofuels will gradually decrease to zero. And there is, so far, high ILUC risk biofuels are the ones that are produced from food or feed crops with a significant expansion on the production area into land with high carbon stock. The directive also opens a new window and introduces the low ILUC risk biofuels, bioliquids, and biomass fuels, which are the ones produced from feedstocks that actually avoid displacement, and that's where we are going to focus today through crop yield increase, by employing agricultural practices that can actually, on one hand, nourish the soil and the ecosystem, and on the other hand, produce substantial raw material for the industry to be able to proceed on an annual basis, and through cultivation of areas that previously were not used for crop production. And this is unused, degraded, or abandoned land. And here we also have a presentation of how such types of land can be cultivated. When I'm talking about agricultural practices, I'm just grouping here the main set as is being defined. Actually, the definitions of the agricultural practices are being developed as we speak, because this is a horizontal integration between agricultural terminology and terminology for renewable energy. And these include intercropping, which is crops grown between the planting rows or of the main crop, and they are intended to be harvested or to be supportive to harvest the main crop. There's a rotational cropping, which include cover crops, and means it's a temporal alternation of different crops on one piece of farmland. And there's agroforestry, which actually combines livestock or growing food crops or other crops on land that also includes trees. That can be for products, fruit trees, it can be for firewood, it can be for timber, and all these happen in one piece of farmland again, and it can include not only other arable land, but also shelter belts, riparian zones, and buffer stripes with woody crop species. When we're going to yield increases, there are several projections, and the European agricultural forecasting provides the increase. This is an example from the cereal yield outlook from the European Commission. These are the numbers from 2020 from DG Agriculture and Rural Development. And you can see that there has been a growth up from 1993 to 2008 of it's a differentiation between the European Union of 15 countries, which is Central West, and Central East is the red line. So you can see the yields were already quite developed in the European Union of the 15 members. So the increase has been on average 0.9 per year, and then dropping to 0.6, because again, the yield adaptation, the crop adaptation and the yield ability has reached its biophysical improvement, while the increases in the other member states have been significantly bigger, 2.3% and then 3.2%, which shows better agricultural practices, better varieties, and the forecasted yield from 2020 to 2030 for the improving countries is 1.4%, while for the western part is 0.5%. If you apply these figures, this is work we are already doing. I will explain. If you apply these figures for soft wheat only, and you adjust the underperforming countries, you pick up the case, for example, of soft wheat by 2030, you can see with orange, you can see the additional, with blue, they are the yields of the countries for the forecasting for 2021. It's not closed yet, but you can see a 30% increase in the production of soft wheat, and we're talking about 2 million tons per year additional. And this is only soft wheat, so you can imagine what can happen if we add the rest of the crops. When we go to land abandonment, there's a recent study by JRC on the potential risk of agricultural land abandonment, and overall, the numbers illustrate that from 2015 to 2030, the average abandonment amounts around 4.8 million hectares. And this is the land that's on risk to being abandoned only. When we go to marginal land, there's a project called MAGIC, where there's a lot of work that has been done on the analyzing which types of land and which marginality constraints can be found in the European Union and beyond. And this has resulted in estimates of approximately 62 million hectares being estimated as marginal. And with marginal, we mean biophysical marginalities, such as risks of dryness due to desertification. We mean soil contamination. We mean increased soil moisture and other types of restrictions that make this land marginal. The available information, the presentations will be available, and the links will help you find more details should you want to do so. And as I mentioned, marginality challenges are not always the same. So when you're planning your crops or your agricultural practices, there are issues of low soil carbon, there are issues of soil contamination, soil erosion, and dryness. And these are risks that are deteriorating as we go through the years. But it has been written, and there are many research colleagues that are performing work at the moment. But the type of agricultural practice you apply to the soil improves or deteriorates further the condition of the soil. And as a general rule, there are certain agricultural practices and perennial species that improve the soil a lot more. For example, cover crops, crop rotation, and perennial cropping increase soil carbon, increase the quality of the soil and the ability to hold on to risks of erosion from wind, from rain, etc. Again, recent work we have done within the MAGIC project, we have worked with cases of using marginal land and cultivating industrial crops, mainly perennial crops. And the next presentation by my colleague Emiliano Maletta will also explain how important these crops are for marginal land. For restoring marginal land on one hand, and on the other hand, for providing sustainable feedstock. These case studies we have investigated are around across Europe, in Greece, Italy, Spain, Germany, Hungary, Latvia, and Ukraine. And we have worked with severe low soil carbon, soil contamination, soil erosion, and dryness, and examined cases where people in these regions have established perennial lignocellulosic crops, rye, lavender, and they have been working and applying practices that actually, on one hand, restored the soil and the land, and on the other hand, offered opportunities to the farming communities. And as I mentioned, we are also performing some new analysis on trying to understand the opportunities for low ILUC feedstock in the European Union, working on baselines for what actually is the current situation of the yield across the member state and the European regions for cereals, for sugar, oil, forage, and lignocellulosic crops, estimating and modeling the estimated productivity increases from different crop characteristics or from different agricultural practices. And as I've illustrated, an average figure yield increases in underperforming regions. And we are further refining the findings of the MAGIC project that I mentioned, working also in combination with the FAO databases for crop suitability and crop yield simulation to understand the actual potentials of crops in marginal land for 2030. Having said this, I hope I've just opened the floor for the coming speakers that will actually touch on the detailed subjects of the perennial crops, as I mentioned, in marginal land, and then on agricultural practices that can help increase crop yields. One with the climate smart agriculture, and another one with examples of 5-year rotation between food and energy crops. Thank you very much, and I would like to welcome Emiliano, who will actually discuss his experience through long-term research for perennial crops in marginal land.
Thank you, Poppy. Great presentation. Thank you. Okay, I am not sure if I should present myself by sharing my screen.
I think so, please.
Okay.
First of all, welcome and thank you for joining us. We look forward to hearing from you.
Thank you for the invitation. I will try to share. Everything is in German here, so I'm trying to figure it out how to share.
It's a button right where you can start your video.
Freigeben.
Exactly. Yeah.
It's let's check if I can find how, because it's not sharing automatically. It's making me open something inside my computer, I think, to allow the application. cannot see how. Can you?
Otherwise, I can just share my screen. It's fine.
Like I am not
Let's do
this
it.
mic.
I will share my screen too.
Sorry about that. Okay, thank you so much. Okay, I will try to I will be a little bit quickly in each slide because I tend to put too many, I think. So please begin with the first one, please.
Emiliano, just to say, feel free to take your time. It's a very important topic, and your experience through the years and the different, let's say, agroclimatic contexts is really, really important, and we will touch upon that on the discussion. So I think we have time.
Okay. Okay, I will put the next, please. This is just about the company, our members. This is starting about the marginal lands, and well, these are the figures in the studies using FAO data. We can see that farmland in the world is not increasing in acreage. This is expressed in prices, but at the end of the day, what is increasing is the productivity, and lands are then used for food or industrial crops or forest or conservation, wetlands, protected areas are summed. In the next slide, please. This you can see the figures, and there is an estimation about. Put it in the next, please. Next slide. Okay, this one. Estimations on prime and woodland available and marginal land. Most studies are providing large area to be for the expansion of new models or new systems. These estimations in using the data from FAO and in these studies are summing about 2.9 billion hectares available. Of those are more than half are marginal lands. Then you'll see very suitable, marginally suitable for both categories. And this is excluding all land used for food, plus all the protected areas and other lands with permanent crops or pastures, permanent meadows, etc. Okay, put the next one, please. So the other studies are also providing information on how much land would be used or could be used potentially for bioenergy crops or biomass crops or different systems, which most of the estimations are between 50 and 200 million hectares, which is a very, very teeny share of the total potential. We just said before is almost 2.9 billion hectares. Next, please. So about regenerative agriculture, first to say that we are trying to put that. I mean, my work, particularly with our project, is to try this in industrial crops and agri industries and larger scale applications. Besides of the needs in Europe are maybe different from the context we see in Africa, Latin America, Asia. However, even here, the criteria tends to be including the different dimensions we normally include in most evaluations, also in life cycle assessments. Regeneration conceived by the developers of the regenerative agriculture or regenerative farming systems in general are very well developed in smaller scales, small horticulture, gardens, stuff like that. So we are considering these dimensions, but we are considering also industrial crops and larger scale applications. To the next, please. I will start moving a little bit with photos in the next slides that are including the systems with grasses or short rotation copies options, legume trees, different kind of forestry, fast growing, conventional forestry as well. We've been involved in different projects in Europe, in several countries, also in different kind of networks with research and development projects across Spain, Italy, Eastern European countries, partners and people we work with in the UK or in Northern Europe as well, in Germany. So most of the systems in temperate areas are having cool and warm grasses, which are C3 and C4 photosynthetic pathways, and can be very high yielding, besides of the different implications in the planting methodologies, and if they are seeded grasses or they are using rhizomes or they are using different nursery requirements. For the short rotation copies or the different species on woody systems is the same. So we see a little bit on the different implications on getting the larger scale we consider here for the logistics. Next, please. All grasses in tropics are also very similar, but with a completely different productivity. We go up to 45 dry tons hectare per year, which are very well documented for even seeded grasses like guinea grass or panicum ecotypes like switchgrass itself or other kinds. There are a number of other grasses that are not seeded. Put the next, please. Which are grasses like Penicillium purpureum or the hybris or energy cane, which is Saccharina spontaneum, similar to sugarcane, but with more fibers content. Put the next, please. This is implemented all in larger scale, so we know very well about the implications on monocrops and polycrops with trees as well. There is pedigree materials, licenses, everything is very much mature in terms of the development in the tropics, and it is moving forward with perennial systems that normally last 7 to 10 years. Put the next, please. In short rotation crops in the tropics, we see also agroforestry is more present than in temperate areas. But anyway, different systems with legume species, or fast-growing species, even Bologna, or even eucalyptus itself, or acacia, robinia. Different species are present in the landscape and in different projects. Even in Europe, we see in marginal lands woody systems with other species like Siberian elms, or for example, there are some bush models that are interesting. Also in Spain, we see some of those. Some are in combination with essential oils and other kind of products. So there is room for multiple purposes and combinations of species. The problem is normally in Europe that, different from the tropics, the larger scale operation is more complicated in some specific areas with marginal lands. But put the next, please. Well, this is examples in temperate area with poplar, different harvesting solutions, commercially developed in most cases for planting and harvesting operations with trees. And this is also compatible with alley cropping, with perimeters, and different combinations of species. No? To the next, please. In semi-arid lands, well, here is maybe the core of what I wanted to tell today. In very marginal lands, problem is productivity can be extremely low, and then logistics need to be justified. So in terms of combination of species and harvesting schedules and the implementation of all these, some areas are interesting with harvesting every 8 years, for example, where you can see that the biomass ton harvested on trailer has a very competitive cost, and sometimes they are used. That's also like a case in Southern Europe. On the photos here and below, you see also a bush model with a triplex numularia. This is northern Chile, 200 millimeters rainfall, extremely arid, and they harvest every 8 years, and they have the possibility to use the fodder and the wood. Put the next, please. For agroforestry systems, well, there is also there are a number of projects that combine. Even in Spain right now, we are seeing an example with hemp being grown for different kind of byproducts, combined in combination with different kind of trees, even fruit trees. And they have the pruning, and they integrate both things with different farmers in small units in northern Spain, for example, in Galicia. Some advantages of the management is that the trees can be harvested every number of years in mechanized manners in combination with intercropping. Put the next, please. This is just an example of agave and cacti and different kind of species that are developed in semi-arid lands. Some of those could be eventually viable for Southern Europe in some places. However, there are environmental implications that sometimes can be complicated. So that take us to a very interesting discussion. It is if we recognize that the current scenario is absolutely negative with desertification, erosion, and different implications, green covers in some specific locations. Case of southern Spain, which is completely, it's a very, very important challenge here to track green covers, perennial green covers. Most of the agriculture is like low yielding winter cereals with annual operations and plowing. So areas that we see in Andalusia have been implementing projects that are using technology from Mexico. So that's another good story. To the next, please. So just to give an example, this is some machinery operations that are also commercially very well developed, both for planting and harvesting, even in bush management, in native forestry, and with the number of species that are harvested selectively with different kind of machinery. So there is everything absolutely. It is very clear that we can do it and expand it, in a way. The problem sometimes again is about the property issues with this very small scale operation you need with smallholders and farmers in Europe, which is very low scale sometimes. Put the next, please. Operations using biochar, biofertilizers, composting materials are also in place in several locations. We are involved with cooperatives growing blueberries that they want to use the pruning or the waste materials from agricultural waste materials to compost that together with elements from the animal system. In the case of bioenergy, if you go to regenerative farming concepts, the problem is that normally the soil regeneration requires inoculation, manure, and different elements to increase the soil biodiversity. That is increasing with the perennial system, but can be boosted when planted. So you plant and maybe apply in the next year a number of products that are enhancing the bio diversity in the soil. Put the next, please. Just take a consideration the photos here because we need to move faster. This is biochar application. Put the next, please. This is interesting about the biochar is how is the perdurability in the soil. So a number of samples of composting that is disappearing next year because of the conditions, the soil when it's so marginal. Examples in Africa with mining sector, reclamation lands is also an interesting consideration for some places. Pollution and all about phytoremediation with perennial trees is very advanced, and soil strategies with biochar, soil corrections for the pH, etc. So put the next, please. And mining is very interesting also for the energy use. They normally plant because of the social responsibility. So the approach for regeneration, considering in a way the biomimicry possible for the landscape and the possibilities you have to at least favor the conditions that take you to a healthier system in marginal lands. That's compatible with biomass growing. You don't require, like in maize, 15 days previous anthesis or flowering, and 15 days later, a lot of nitrogen of water to get the yield. In a comparison with the woody system, the requirements are in the perennial system are much less, and the inputs required as well. So that allows you to create biodiversity, different patches in combination with the rotational cropping, with the food crops you have in the same region. And this gives an opportunity for a restorative approach, acting more similar to nature in each environment. Put the next, please. Well, this is just a toolbox from groups that work in different aspects with regeneration. Of course, a lot of study of the area and very accurate information on the physical environment, plus design considering the water, the biodiversity, so the organic matter is also very much relevant for the bioenergy implications. And so the regenerative agricultural toolbox is absolutely compatible with this when it comes to biomass. Actually, there are few species or few options of perennial cropping systems, woody or herbaceous, in many regions. That there is a lack for competitive alternatives, and the biomass is giving us a little bit of an opportunity for the combinations, with synergy with food production, of course. Put the next, please. Well, there are principles on soil, water, biodiversity, and ecosystem health, and of course, the carbon that are also typical in regenerative agroforestry. Put the next, please. The indicators and the different conditions you are considering for a biomass project and biomass harvesting or a logistic chain development in the landscape. For this example is in the Mediterranean, but this is relevant for any place. Should have to include the different dimensions, which can be challenging sometimes in terms of the economics. To the next, please. Well, all the environmental advantages of perennial systems are very well known and described. I don't want to put a lot about that, but of course, all the routing systems and the advantages of biodiversity are very well documented. In this presentation, I have attached the sources of the different studies and figures. To the next, please. This is a photo past week on a switchgrass bioenergy crop in Canada by Roger Sampson. This is perennial system that we could have it also in Europe, right? Well, there are dozens of studies to get the reference on miscanthus and willows and on switchgrass, tallweed grass, several perennial bush systems and systems we see in the Dehesa in Spain, which is very arid in Extremadura, for example. There are different systems that have been documented about their advantages or benefits in terms of biodiversity. So that's also very well documented and compatible. Put the next, please. These are examples, and this takes us to the question of how marginal it is, what is happening today, and what could happen with an intervention in different environments. About the reduction in erosions, the improvement with the green covers and organic matter or carbon. And the issue here is that most of these systems are criticized because in a way they are monocropping or 2 crops or 3 crops or industrial cropping in a way, and people prefer abandonment. That's curious, but we prefer abandonment and fossil energy than renewable energy and green covers, and permanent green covers. But eventually the consideration on the context, on the scenario, on the land use change compared to the reference today, and what is going to be the result and indicators. Put the next, please. A lot of water is interesting as well because, of course, the hedgerows and the different options with grasses or grasses and trees, or grasses and grasses, like in this photo, these are 2 grasses planted in a very low cost model. That is, the expensive grass yields a lot, but it's more expensive to plant, and the hectare is not giving us all the potential for it. So we combine with a cheaper grass that is seeded and it is combined as well and harvested. Right? So these kind of things are helping all about the water economy as well. Put the next, please. So they take us to this graph, which is that the ratios and Woody models have different the exact point where the yield is too low and it starts to be too expensive to go there and harvest, you know? And then in woody systems, well, under analyzed yields of 5 or 7, we see that there are challenges, and the cost tends to be too high in terms of the biomass put on a trailer in a farm gate. And the increasing in yield can be very interesting as well. However, in this graph is not shown, but there are some exemptions and outliers you can see, and then eventually you can see some ratios models that are very cheap, even under very low yields. You know? And that's maybe because there are marginal lands that have opportunities for the grasses, and the grasses can be very, very cheap option in order to establish one perennial system for 10 years or 20 years sometimes. Some are seeded and they regrow alone. So it's eventually go there to harvest when it's ready. But the ratios crops have a biomass that is not going to stay on the ground for a lot of time. So with the woody system, when it is very low yielding, you can wait 8 years to go harvest every 8 years or 10 years, no? And that's changing the situation with the cost and the yields and very, very low yielding areas. Put the next, please. So highly productive sites have another problem compared to marginal soils where you want to regenerate this. And the main point here in this chart, in this comparison, is about the opportunity cost. High yielding areas, like we see companies growing miscanthus in Iowa or trying some bioenergy options and high yielding crops in competitive areas, even in Europe and South America. They are competing with sugarcane, or they're competing with maize, or they're competing with the livestock, or whatever is the opportunity there. And that makes the farmers to ask more money for the ton they are delivering. So at the end of the day, it is a cost that you need to pay as an industry. So we see that in the marginal lands, that opportunity cost is lower. So put the next, please. Here you see that the site quality gives you high opportunity cost, and the opportunity cost is giving you an increment in the cost per gigajoule delivered. So that's when you go in higher yielding areas, you have a higher opportunity cost. That makes very reasonable to start considering ecological services and other different kind of dimensions for the regeneration and the integration in a regional scale in Europe when it comes to the logistic chain and the marginality of the soils and the opportunity options they have. Put the next, please. Well, that's the whole thing. You need a low footprint biomass delivered. So that takes us to low production costs, low emissions, low fossil energy required, positive externalities, efficient cultivation, low cost establishment techniques for the perennial systems that are going to be in very marginal lands. You need logistic models and harvesting operations to be very well organized. And of course, a low impact in terms of water requirements and inputs, and then it all comes to how the system will regenerate in order to be able to have a stability in a way that might be obtained after 20 years or 15 years of regeneration and perennial models with more biodiversity and positive externalities, right? To get there in order to save water, mulch, organic matter, and all the soil improvement you need to save water and increase the yield of the biomass. And in the analyzed systems, you can and analyze the cost that you have in different systems. Next, and I think we finished. Well, final remarks are maybe what I just said about the advantages, having the advantages, but consider the logistics, consider the cost of soil amendments, and times considering the current land use and the realistic improvement you can have. Of course, this is all relevant for policy making, and the decisions for the different operators and their institutions in each country to promote healthier systems that can be integrated. I think that thermal energy, in particular in isolated regions, are given the opportunity to provide relatively cheap and low footprint biomass in isolated regions that normally don't have the gas or the logistic to access the thermal energy can be difficult. I saw that in northern Spain, in Mallorca, in Sicily. I saw that in Romania, different areas, and that's something you see. They don't have the thermal energy, and that these systems are given the opportunity to boost or transform a little bit the products and increase productivity in some marginal areas too. So that's the whole thing, creating some social benefits. That's the expectation we have. That's it. Thank you.
Thank you very, very much, Emiliano. Just to mention and draw the attention to colleagues, I'm sure most of you will have seen that there's a chat, and there are some comments. Before leaving from this topic of marginal land, I would like to mention that thank you, Emiliano. I will just stay to the phrase, there are no magical crops. You have a system, and it is an agricultural production system, and our system needs to be adapted to local conditions and the local context. It needs to be improved based on the agroecological conditions. It needs to be communicated to the local community, and it needs to be understood by everybody that you're talking about a dynamic system. Agriculture is not finite. It's regenerative and can be regenerative. It has been for years, so it can continue to be with improvements, with transparency, and with solid knowledge on the ground. Last about the marginal, underutilized and contaminated land. Thank you, Rainer. Our colleague Rainer Jensen has mentioned that they have in a Horizon 2020 project, Bioplat EU, there's a very interesting and useful web GIS tool investigating these. Again, it is in the chat, but we will also make sure we put it into the minutes so that the information is there, because all the tools are very useful. There's a similar one to the Magic project that I mentioned. So I think there is increasing evidence and transparency from all these very good initiatives through Horizon 2020. I will just take the opportunity and respond quickly. Of course, this is a big topic. There are here two questions. There is this issue about young farmers and the aging farmers. So if we cannot really attract young farmers to take on good land, how can we attract them to actually get into the mess of converting, restoring, rehabilitating marginal land? I think it is marginal because there is no policy and institutional framework surrounding it properly. I'm sure Emiliano will intervene. So for sure, through the new Common Agricultural Policy, the Green Deal, the Fit for 55, you can develop attractive packages for these sort of ecological services that Emiliano mentioned. So Emiliano, that's a very short reply from me, and Emiliano, please.
Yeah, absolutely. I think that the point here is the business models that can be developed. In the case of Europe, we see some marginal lands where farmers are losing money, and there's a big crisis. And we see in many countries in Europe, I can see that a lot in Spain, which is in the map you had. Probably is a big land that can be considered for biomass, because they really don't have the opportunity to grow grasses and be competitive, or try winter cereals sometimes and be competitive. They go minus €100 an hectare at the end of the story, and with a subsidy they go 0 or they go plus 100, and that's the whole thing. And with perennial systems, sometimes they had an advantage, and we saw that in some projects. Regarding the yields and the low productivity in the last question, this is a very good it's a very good thing about low productivity takes to a high cost. Well, I can take you to some examples that are completely the opposite, which is so amazing, because it's true, of course, that if you yield less, your yields are lower, your cost will be higher. However, there is a common misconception about it. Sometimes you go on larger scales with lower yields, and you have a final delivered biomass cost that is lower, and the footprint can be lower. And that's amazing, because some kind of systems, like in some marginal lands, you have a bush system providing you a very low analyzed yield, let's say 3 dry tons an hectare per year, and you go after 10 years and you go and harvest 30. So your logistic cost is not going to be so high. You're going to harvest 30, not 3 every year. And the perennial model is you have a capex with establishment, and then you only harvest. So you don't have a big opex every year. So at the end of the day, what my point is that by increasing the hectares in some marginal lands, you get a lower end cost when they delivering the biomass. Sometimes it happens, and instead I saw miscanthus growing with 20 dry tons a hectare per year being more expensive. I had that experience too. So it is,
again, it's the context of where you cultivate, and how the cultivation can actually improve the system and increase the yields. Right. We took a little bit longer in this session because this was the one. Thank you very, very much, Emiliano. No, it was important because you covered alone the topic of marginal unused land, while now we have 2 very important speakers talking about the practices for crop yield increases. I would like to welcome Marko Janhunen from UBM, who is actually going to talk about a very real, very large scale and very industrial operational case, the case of carinata that UBM has been growing for quite some years, adding value to local farmers in Uruguay, and also ensuring that it is integrated into soil conditions as a cover crop that actually sequentially is integrated in the system. So Marko, we look forward to your presentation.
Thank you very much. Can you hear me well?
Yes, very well.
Well, thank you very much. And I guess, first of all, thank you very much to ETIP Bioenergy for setting up this week of very interesting events, and warm thanks for the kind invitation to be here and present some views. I guess comparing to where Emiliano was coming from, I'm really trying to give some insight into how we have tried to develop our practices with the main question that what is actually the driver that then enables large-scale investments. These for the great examples on marginal land that Emiliano presented. How do we make them and other projects really take off? What needs to be done from the industry side and from the regulatory side? I hope you can see my slides now. And I'm going to give a very quick overview of why this is an important issue and why the journey of UPM, which is a large forest industry company with operations around the world, first of all invested in biofuels, advanced biofuels, and why we have, you know, transformed. Really, it's a big step, starting from forest industry, pulp, paper, timber products, and so forth, to advanced biofuels first of all, and then going to agriculture sector, which has completely different drivers. And what we try to do is really combine the knowledge from these different aspects and create advanced biofuels that help to decarbonize the transport sector. And really the key question for me here is what role for agricultural feedstock. And I do hope that you will let me know if you don't see the slides changing. This here, as also you can see behind me, is wintertime in South America, in Uruguay, where we are cultivating a winter crop, cover crop, sequential crop, Brassica carinata, for 5 years now. We have cultivated over 50,000 hectares cumulatively, roughly 10,000 hectares every year. And this is again a case where it's not as such crop specific. We also like to talk about the model. What is the model that enables positive practices to be taken into use, and that enables then the development of a sustainable biofuel sector on one hand, but has multiple other benefits to the society, to the agricultural communities, etc. We are, as I said, about 19,000 employees around the world, with operations in all parts of the globe. One long-standing traditional forest industry company that is currently very strongly transforming. As an example, not only have we invested in this Lappeenranta biorefinery, currently we are building first of a kind wood-based biochemical biomeg biorefinery in Bologna, Germany, for 550 million euro, entering the chemical sector as well. Though here in the Lappeenranta biorefinery, we also produce substantial amounts of renewable naphtha for the bioplastic industry. This experience has been very positive, and therefore we are considering a new investment either in Kotka, Finland, or Rotterdam, the Netherlands, to produce 500,000 tons of renewable fuels, where we are looking at a number of novel and sustainable feedstock. And really the name of the game is that what are the feedstocks of the future? How can we actually start again collaborating between the agriculture sector and the fuel sector? What can we do to advance these investments, which would enable new novel renewable fuels for both heavy duty, for passenger cars transport, for all modes, including sustainable aviation fuels. These obviously would also involve great innovations and first steps in the use of green hydrogen. So there's a lot of positive elements combined. What we are mainly looking at, that as we see quite an increase of these investments in renewable fuels, we want to try to identify such feedstock that take us to next level of sustainability. And we believe that sustainable agriculture, cover cropping, sequential cropping could be a remarkable opportunity. I will come back to the reasons why it doesn't actually seem so at the moment, due to some regulatory changes, but I will save that for last. The reason why we believe that there are a number of business opportunities is that the challenge is sizable, as you can see. We have done thousands and thousands of Excels as part of the business plan, looking at where are the markets for renewable fuels, what are the technological options, what are the feedstock options. But no matter how you look at it, we will have a sizable legacy fleet in the passenger vehicle market. We will have commercial vehicles. We will have maritime aviation markets that will require sustainable renewable fuels. That is for sure. How they will be produced, where, by whom, what are the concepts, that obviously remains to be seen. Now, what we really, then this is a simple illustration of what we are trying to do. We've defined our project in Uruguay as climate positive farming. We are taking land into use during no use period in wintertime, where the benefit is obvious that if you do put something in the land, you will limit erosion, you will create more biomass, etc., etc. And we can, in the conditions of Uruguay, do this in a very sustainable way by not interfering in the growth of the main crop, which in most cases today is soy. So we are growing Brassica carinata or some other crops from the Brassica family from December to May, from May to December in the South American wintertime. And the point really is threefold. It's additionality, it's the carbon sequestration, and improved soil productivity. A little bit more in detail, and of course I could go in much more detail. You can find also plentiful of material on the projects on our website. But we go approximately every 3 years to the same area. We are planting mainly Brassica, but other crops are also possible. And the diversification of crop rotation is very important for pest control. We are looking at external carbon inputs also, and that could be very interesting. And of course, very important is that there is no tillage taking place. The benefits are quite clear. Again, improve the quality of the soil, higher rates of carbon biosequestration, increased yields and productivity, no land use or change, crop displacement. So this sounds probably too good to be true. How we've done this is that obviously there is in the current Renewable Energy Directive a possibility to use soil carbon sequestration, so-called ESCA value, and enhanced soil carbon approach, whereby there is a system how to calculate the greenhouse gas additionality from these practices. Now the Commission has now recently made a proposal on changing that system. There is a consultation, or there's actually a process now very far, almost finalized by the Commission and Member States on implementing Act on voluntary schemes, whereby the modeling way of doing this, where we take the IPCC values with a lot of work, this practice would no longer be possible, and all of the ESCA verification would need to be done by monitoring. In our case, on our 10,000 hectares, which is still for us the pilot, whereby we would like to grow it many-fold, it would mean around 50,000 samples per year, which I'm sure you can imagine is quite burdensome. So this leads me to raise the question, really, and I'd be really pleased to discuss it with the other panelists and of course our audience. What are the measures that we would need to do for this to be true? Because I think all of us recognize that biofuels and sustainable advanced, whatever you call them, biofuels play an important role. We also probably, with many of you, agree that there is a huge potential of innovation. And it's a huge potential also of win-win, where both the agricultural sector and the industry can benefit from these novel practices, taking them large scale, taking them to the sufficient size where you can then make considerable investments. Our investment would be, which we are planning at the moment, and going through the business case obviously still, would be around 1 billion euros. And these kind of practices would definitely need to play an important role in order to take the sustainability of the advanced biofuels business to the next level. In addition to this process of implementing Act on voluntary schemes, there's also the revision of the Annex 9 Part A and B ongoing, which, according to the reports that have been so far published, doesn't look too promising for cover crops. Again, we see the opportunity. I think there's a lot of academic studies providing very good input to the discussion. There have been tremendous amounts of studies. There are companies ready to invest, but it seems that the policy is not really exactly following. So with these words, Poppy, maybe as a final remark, one of the challenges we obviously see that we are undertaking this in Uruguay, where UPM has been operating in the plantation business since 1990. We have a long tradition. We own sizable amount of land for eucalyptus plantations, around 400,000 hectares. We've invested 5 billion in Uruguay already in 2 pulp mills. But we also want to collaborate at European level, and therefore, Poppy, we are engaged also with you in the bike project that you presented as well, which I should obviously have here as well, which is an important kind of, how do we take these models that may work somewhere else? How do we make them European? They probably, winter cropping in Finland won't really work for many decades yet, but and hopefully never. But there are lots of areas in Europe where this would be a tremendous opportunity. So with these words, Poppy, I'm happy to join the discussion later on.
Thank you very much, Marko. It's very important. I see a couple of comments on the chat, but we will touch on that. It's very important forward that this carinata is not a monoculture. It is integrated within a system, an agricultural system, and this is how it will be also integrated into European agricultural systems. Yes, we will touch on that during the discussion. I would like to Parenti now to actually illustrate how food and energy crops can be combined and integrated, which is the argument in debates for many years has been that it's food or feed or energy crops. But let's see how the results from the Be Cool project that Andrea is going to present can prove that there are other opportunities to broaden the feedstock than saying this or that. It can be both.
Okay, good afternoon, everyone. Thanks for the invitation and for the nice introduction that you made.
Andrea, if you could make your screen into a presenter mode, maybe people would see it bigger.
Okay, can you see it bigger?
We see both slides now, so I think it's still...
You need to switch when you go on the top, in the middle. Impostazioni.
Where is it? Here?
Exactly, in the first one, I think.
Okay.
Now it's fine, yeah.
Okay, so today I'm gonna show you the results of 5 years food and energy crop rotation where we evaluated the feedstock quantity that we produced, the quality, and how this influenced the advanced biofuel value chain that we are studying. So this the work that I'm showing you is in the framework of the BCool project. That is a project aimed at strengthen the European and Brazil cooperation on advanced lignocellulosic biofuels. It started in 2017 and is going to end next year. On the EU side, we are 12 partners, and the project is coordinated by the Professor Andrea Monti of the University of Bologna. This is a little bit of the workflow of the project that is divided into 3 vertical pillars. The first one is on the biomass production. The second one is the logistic, and the third one is the processing. I'm an agronomist, so I'm dealing more with the first pillar of the project, but I'm going to show you a little bit of everything in order to give an overview of what is the value chain that we are building up. So the value chain starts from the feedstock production. We are evaluating different feedstock, some coming from perennial crops from marginal lands, other from agricultural wastes, but in particular in this presentation, I'm going to focus on the feedstock that can be produced in fertile lands. In case then we go and intensify the food cropping system by adding energy crop in between the food system. So we build up this new integrated cropping system that include lignocellulosic crops that are dedicated to the production of advanced biofuel. This is the scheme of the concept that we had into our mind when we were writing the proposal of the project. So basically, we rotate food crops with energy crop and again food crops. The energy crop that we are growing, that we are cultivating, are added in between the food crop. They are not substituting the food crop. So basically, we are intensifying the system because we don't want to reduce the food production per unit of land. Then the products of this system will be delivered to the logistic part and the conversion part. Of course, from the food crop, we are going to use only the food residues. From the energy crop, we are going to use the whole biomass that we are harvesting. But what are the potential advantages of these systems? There are several. Agronomists know that adding new crop in a system can enhance the soil fertility because we are going to have more biodiversity, and this is due to a positive rotational effect of different crops on the same land. We can produce with this system. We can produce feedstock without competing with food land. We can also widen the market opportunities for farmers. We can build up sustainable cropping system because the crop that are dedicated to the production of advanced biofuel are of course low input requirements, so they need just a little bit of fertilizer. They don't need agrochemicals in general, so they can produce additional biomass in, I would say, sustainable way. Then we can increase the feedstock availability at a regional level, so we can shorten the supply chain that we are building. We can increase the plant size because, of course, there will be more biomass available. So bigger plants can reduce the running costs. And of course, producing the multi-feedstock, we can avoid shortage in case of harsh season for particular crops. We have also to face some challenges with these systems that, of course, we have to identify the right crops to do that. So we have to make a selection. Perhaps the farmers will need to invest on new machinery to harvest these high-yielding crops. We have to build up also a logistic concept and the conversion plants. And we have also to convince farmer because some of these crops are unfamiliar to them, so they don't know and maybe they don't want to grow them. The system that I'm going to show you in a bit were evaluated in terms of the quantity of biomass that is produced and the quality of the biomass. That, of course, influence the final yield of the advanced biofuel. These studies are replicated into 3 locations of Southern Europe, Italy, Greece, and Spain. These are images that were taken this summer from the experimental farm of the University of Bologna. These are the concepts that we developed of the new systems. So basically we have a baseline, a control rotation. That is what most of the farmers still do. So alternating the most common food crop like maize and wheat with some fallow between these crops. So we have some gaps in which the land is left fallow and is not cultivated. So we intensified this control rotation by adding some legume crop, sun hemp, and some energy crop like sorghum for biomass. So it's called biomass sorghum, very high yielding, can reach up to 25 tons of dry matter per hectare. Kenaf, another dedicated energy crop, hemp, and of course, as I said, the legume crop sun hemp. These are the result of 5 years rotation from 2017 when the project started up to now. As we can see from the first 2 figures, starting from the left, the wheat grain and the maize grain yields were not reduced in any of the tested rotation and in any of the 3 locations where we performed this system, this rotation. Otherwise, we were able to increase here in R5 the wheat production because this is a very intense rotation where wheat is cultivated every year and is alternated with the sun hemp legume crop. If we focus otherwise on the right figure, we see that we were able, compared to the control rotation, to increase significantly the biomass yield in the other rotation, in particular in R2, that is the rotation with fiber sorghum or biomass sorghum, as I called it before, and in R5. So these 2 rotations were basically the most productive in quantitative terms. These are some other results that we get. So how this biomass that we are producing in every rotation is made of, is composed. We can see in the blue is the maize straw, so is a residue of the maize cultivation. There in the red color we have the wheat straw, and in green we have the energy crop biomass yield. That is very consistent if we check on the intensified rotation from R1 to R5. The green part is consistent. So we were able basically to go from a little bit more of 20 tons per hectare of biomass for advanced biofuels up to 60 tons in Italy, 80 tons in Greece, and 40 tons in Spain over a period of 5 years, of course. So this is considering 5 years rotation. Then we evaluated in qualitative terms the biomass coming from this energy crop. So we wanted to see the fiber content in the biomass because it's important for the yield in the ethanol yield that they are able to produce. And we measured the cellulose and hemicellulose and lignin content. In particular, we saw that we made an addition. Biomass sorghum is the one with the overall cellulose and hemicellulose content that is highest compared to the other. and it has also the lowest lignin content. In terms of ash and nitrogen content, that we know that it is important that they are the lowest as possible. We saw that also here biomass sorghum is the crop with the lowest ash content, that is close to 4.5%, and also the nitrogen content in the biomass is lower compared to the other feedstock. Then we measured also other inorganic elements that are present in every biomass, and it's important because during the combustion of this feedstock, they may cause problem to the plants, in particular slugging, corrosion, and fouling. Here we saw that again, sorghum is the crop that has got the general lowest mineral concentration. On the other side, hemp, industrial hemp, cannabis sativa, is the one with the highest mineral concentration, whereas sun hemp and kenaf showed intermediate values. Then I'm going to show you a couple of examples of value chain that we are building. This is a biochemical value chain that we are evaluating. So from the crop cultivation to the ethanol barrel. This is a paper that I'm preparing, where also I made, I would say, an estimation of the land availability in the Emilia-Romagna region in northern Italy. And then I calculated the potential feedstock that we can produce in the region by implementing the system that I showed you in the slide before. These value chain are going to be then assessed all over Europe, so not only in one region, and are going to be evaluated in terms of yield, cost, and sustainability. Of course, we have still 6 months to the end of the project, so this is the time that we are performing this sustainability and cost evaluation. This is another example of a thermochemical value chain that we are considering. So basically from an initial reference case study where the biomass is collected is pre-processed into a fast pyrolysis plant that can produce fast pyrolysis bio-oil and that is used in a Fischer-Tropsch plant. Then we implemented, for example, and we are evaluating additional pyrolysis step. So not only the fast pyrolysis step, but for example, we are studying the opportunity to perform also slow pyrolysis that can produce 2 kinds of product: renewable heat for drying the biomass, because it's important that we reduce the biomass moisture content from the field gate to the plant. We have to go from 30% of moisture content to 20% of moisture content, and also to produce slow pyrolysis char. These are just 2 examples that I wanted to give you in order to show which part 2 value chain that we are evaluating over and numerous value chain that we are considering. So at the end, to conclude, from this 5-year experiment, we can say that we were able to increase the biomass yield when the energy crop were included in the rotation. We did not reduce the food production per unit of land. Then we saw that biomass sorghum was the most promising annual crop. And this is also an advantage for the farmers, because they already know grain sorghum, so they are more willing, in my opinion, to adopt this kind of system. But also the other crops that we tested are very interesting, in particular sun hemp, that is a high-yielding legume crop with a very low input requirement, plus being a legume, it has a nitrogen fixing ability, so it can store some nitrogen into the soil. So with this system, we can we can have more biomass availability per unit of land, so we can greatly contribute to the scale up of the value chain. We can add additional feedstock to the one produced from marginal land, for example, and this means that we can reduce the cost of running the plant. So another conclusion can be that these plants that are going to be built need to be adapted to different feedstock, to multi-feedstock, because we will have maybe Arundodonax, giant reed from marginal land, switchgrass, and sorghum from this crop rotation. Of course, I'm open for question if you have any. So thanks for your attention.
Thank you very much, Andrea. I will just keep one element that you mentioned, which is that these opportunities you are investigating for crop rotation basically open a new window to a new typology of plants, of crops, in addition to or complementing the perennial lignocellulosic species. This is hugely important as a message because we understand, and I think it's easily understood, that marginal, low quality, abandoned, degraded land and lignocellulosic perennials are one option. What needs to be brought forward as well is that it is not the only option. There is a great opportunity to integrate the industrial, the non-food types of crops within the food systems and support the rotation and broaden the crops you have on your portfolio in terms of types. And I will also keep, and I think this is a very important message coming from your research and the Be Cool project, the amount of biomass you mentioned per year, that actually these crops helped increase the yield, lower the costs, and still securing feedstock for the advanced biofuels. I can see, I do not see any questions. The floor is open. I only want also to mention what is in the chat about the EC communication for restoring sustainable cycle for the carbon farming. There's a lot of work at the moment from the European Commission, and I think all the findings from presented here by Emiliano, by Marko, by Andrea should be channeled to this communication and to the working groups as contribution for additional feedstock that can be brought forward whilst respecting biodiversity, respecting ecosystem services, and possibly after that attracting young farmers. So I'm not sure if we have any other questions, or I will just ask the speakers, if I may, if you would be asked to mention the biggest challenge and the biggest opportunity from your work, which would that be? And I can see Marko first. So Marko, please. We want the worst challenge and the biggest challenge for your work at the moment, and the strongest opportunity.
I think the strongest opportunity is very well highlighted in the discussions today, different presentations, targeting the issue from different angles. And I think the kind of recognition of part of the business community and especially academic community, researchers, and a lot of people on the field who recognize the opportunity that these kind of projects can actually, they can really transform a lot of things. They're not only, bringing in new feedstock, additional feedstock, they can contribute to the broader change in the agricultural sector that might be, you know, speeded up through these projects. And it's true that the Commission communication, I sent a message to Emanuele Lugato on when can we expect the Commission communication. It's really important, but unfortunately, though, on the other side, and this is my kind of biggest threat, is that there will not be instruments that actually incentivize you to do that. And this is probably going to be most significant in the field of biofuels, where I do recognize that there have been a number of issues in the past and conflicts, whether they are for right or wrong reasons. I don't think we have the time to discuss that. But there is a certain past, and the Commission has taken a certain view on agricultural-based biofuels. And while, yes, we are talking about agriculture here, but it's actually a very transformative process that can speed up the development. And therefore, again, my biggest threat is that many of these projects will not materialize because you cannot find the benefit of doing them. It's quite obvious that what we're doing is not 10,000 hectares a year in a very new kind of environment. It's not easy and it's not cheap, but we see the business opportunity to develop it. But on the other hand, we do need to have some ways of doing it without doing 6,000 measurements per year. And we need to have the right tools to prove the sustainability of these projects.
So if I translate that well, there is an element of, if I can call it, I apologize for the terminology, I think it came through the chat as well, repackaging the way we communicate the benefits of these systems that are on the ground, and explaining the operational issues as well as the CapEx issues for the financing, because the operational element that you're bringing forward now, which is to monitor your benefits, you have a cost which can probably be unbearable, is an issue that has to be communicated further. And I think we can bring it into the minutes, but also to keep the point of sometimes the benefits are not presented in the form that is requested, or the always changing form. And I think as a research community, and of course ETIP Bioenergy is doing a lot of work on that, is to try and repackage them and show the jobs, show the complementarity, so that it is not a monoculture, so that it is actually, it has fit within the local community, and that it goes ahead. And that also, which is not to be dismissed in an era of where everybody is seeking financing and is seeking private partnerships, the fact that big industries see business opportunities, I think is something to be examined carefully, because certainly private money and private investment is not easy to find. Thank you very much, Marko. I'm sure Emiliano, I can see him smiling. He knows very well, as I do, that we don't come from industry, and we know that every time we talk to industry, Emiliano, please, you will say it better than me.
Well, I take a lot of time because I know that we are probably finishing already. Well, I don't know. I think that this also there is a mentality problem here, because regarding the support and the position that we see in policymakers and everybody, there is the fear of things, you know, the fear of the changes. And within the agricultural sector and rural economies, wow, that's pretty big issue. And well, the point here is that sometimes, you know, the typical position is, well, no, let's take care about the food. Well, the food is, I go to the supermarket. It's not that we need to grow everything. You go to the supermarket and you're using food that you want to go with slow food, you want to go 0 kilometer and have fresh food close to the communities. However, they are importing most of the food everywhere, and we are not depending on the food as before. No? Europe is still like dealing with that fear after Second World War. And the truth is that we are not having any issue with the food. Here, the energy is more like a big issue. You can see it these days with the gas issues and the problems. So they're all about the policy regarding this is dealing with that, dealing with the threats on the biodiversity and the environmental aspects. However, we don't care very much about normal desertification going on, pollution like we see in Spain in the sea, that the fishes are dead and floating on the surface in the minor sea near Malaga, for example, because of agricultural chemical going down stream, and there are no options because they just plow and get very little and depend on subsidies. No, so we're subsidizing that and fossil energy, and so the whole thing is about that mentality to change, I think, and that will allow us to consider the bioeconomy and the rural areas and the energy requirement of tourism in isolated areas, of different activities, agro-industries, digital communities, being in the nature. And that's more or less what we see is already happening. And because of the funding is very much available. Our projects are the problem, and the people and management and logistics.
Yeah.
Funding is everywhere. There is a lot of money for this. The problem is not about the money. It's plenty of money. The problem is
it is people.
Projects, and people are failing, and we are keeping the whole thing, holding the previous scenario, and we haven't changed at all, even with Glasgow or everything else. So a big change on how we can help the nature have healthier systems that can provide us with energy, fibers, biomaterials, cosmetics, different kind of products that can be valuable, and try to go in Europe with the highest value possible through technology. And that's not thinking in the next year, and start thinking in 10 or 20 years, because perennial models are cheap, but they need time. That's and we need to change that perspective. And we're used to think we need to grow wheat, we need to grow barley, and you say, wow, barley, but I need to pay you to use 200 kilograms of urea per hectare plus 300 kilograms of NPK per hectare, and then you're gonna get 1,800 kilograms of barley, or maybe 1,500 in Spain, and we are subsidizing you to do that with your tractor using diesel every year, plowing, sometimes burning, like I see in Sicily every day, or I see in Andalusia, they burn every year, and they burning and plowing for that wheat. And that's the whole model they have, and they don't have any problem with keeping that.
Yeah, I think it's a mental shift as well into people's mind, and this is very, very important. Thank you very, very much, Emiliano. I will leave the last word for the opportunities and challenges to Andrea, as he has been experiencing them through his research in Be Cool.
Thanks. I will be very quick. To me, for the challenges on the side of the industries, one challenge should be to attract the investment of the industries, because they can really start this value chain by investing in a certain territory. From the farmer side, the challenge to me is going to let them know that it's possible also to reduce the plowing and some management that deploy the carbon from the soil, and maybe shift to more sustainable kind of management like minimum tillage or no tillage. So these are the challenges that I see are bottlenecks. For the opportunities, as we showed, to increase the biomass per unit of land, and we can work together with the crops that are coming from marginal land, abandoned land, contaminated, polluted land. We can build a value chain with all these different feedstock. Plus, we can increase significantly the biodiversities of the system, because if you drive around some places where the agriculture is very intensive, you will see only 1 or 2 crops every year, and the biodiversity is very low. With these new crops, we can increase the biodiversity, and is a really good opportunity.
Thank you all very, very much. And apologies, we've chipped to your coffee break, but I think it was a very interesting session, very informative. Emanuele, thank you very much. There's the link in the chat of the regulation. It's important that we all have a look at it and also try to see how we can inform, because the main message I keep, which unfortunately keeps coming back because everything is changing and rapidly, is that we need to prove we are doing no harm, but we are doing good, if I can use some of the no harm practices that are happening. And because we believe we are doing it and we have facts, I think all of us need to put these facts forward to the extent our work allows it. So, thank you all very much, and we will come back. I'll pass it on to the colleagues at ETIP to guide us for the next session. Have a nice afternoon.
Okay, thank you so much. Bye-bye.
Bye.
Thank you very much, Poppy. Thanks a lot to all the speakers of the session. We will proceed with the panel debate at 3:45, so in 7-8 minutes time from now.
Okay, thank you.